Troubleshooting EIGRP. Here is your EIGRP flyby. First thing we want to do if we want to enable EIGRP in this network shown in the picture is go to each router and choose that autonomous system number that has to be the same between all the different devices. So I'll do router EIGRP and we'll just use 10, and it has to be 10 on every single one of the devices. Now we need to identify the networks, and we do that using the network statement. Now, unlike RIP, we have a little more flexibility with how this network statement works because we can use a wildcard mask. So I can say 192.168.1.1 specifically and do a wildcard bits of this, and it's going to enable it on exactly that interface of router 1. So when I hop down here to router 2, I can get a little more broad if I wanted to and do something like router EIGRP 10 network 192.168.0.0.0.0.0, or wait, 255.255, there we go, and enable it on both interfaces at the same time. I see my neighbor forming on router 1 already. Hop down over to router 3. And I'll do same kind of thing, router EIGRP 10 network 192.168.0.0 with a wildcard mask, focusing only on those first two most significant octets. And now I should form that neighbor relationship with router 2 and be advertising it at the same time. I can do a show IP route, and I should see that I now have IPv4 version RIP. Wait. My mind is melting. I'm now seeing that I'm running EIGRP for IPv4 on all routers, and I'm seeing that router 3 is noticing the 192.168.1 network being learned, and it already is directly connected to .2 and .3. If I hop over to router 1 and do a show IP route, I can see that it's seeing the two networks that it's learned via the EIGRP process as well. Now let's hit some of that misconfiguration. What is that? It's miscellaneous. All the other stuff that would go under EIGRP. So first off, what happens if we enable EIGRP on that 68 network up there, right? Router EIGRP 10. And we'll do network 68. Let's just do 110.171.98.0.0.0.0, right? Just verify that that interface is alive and well. Well, it's there, but it's actually not well. Hang on, let me see what I oh, I forgot to enable the ISP side. Hang on. There we go. Now the interface should be up. It sure is. Now let's take a look over at the routing table of router 2. Show IP route. And see if I see that 68 network. I do, but there's a major problem. Anyone see it? It's a /8. It actually dropped it back from the /27 that it should be to a /8. Why? Because by default EIGRP operates classfully. Now this is iOS dependent. Some flavors of the iOS do not have this on by default, but we need to go into every single one of our routers and do router EIGRP 10 no auto summary, which turns it off. It will cause a reset of your neighbor relationship, so it's not something you want to do during the production hours. So we'll go into router 3, our last one. Router EIGRP 10 no auto, right? Now we should be able to see, let me hop to router 2 where I've got the neighbor relationship reformed. The 68 network, sure enough, being advertised with the complete subnet mask of /27 and the correct network that it is. Good, good, good. So I've turned off auto summary, but what if I really did want to summarize that route coming from the ISP? I want to have this operate as a classless routing protocol, but I want to do summary routes wherever I want to. Well, that's one of the major advantages of EIGRP. Matter of fact, let me hop up to router 1. Is I can go into interface configuration mode. Let's do fast Ethernet 0/0 and do an IP summary address. We get to choose which protocol, EIGRP, and we'll do 10 as the autonomous system number. And at any place I want to, I can come in and say, well, I may not want it as broad as 68000/A, but let's summarize that thing down to 68.110.171.0, right, with a Class C subnet mask. Bam. Just like that, we're now advertising a summary route. It resyncs with its neighbor down there, and I should be able to see this thing move from a /27 to /24. Sure enough, it does. So that's how easy it is, and that's one of the huge advantages of EIGRP is the ability to come in and inject summary routes whenever and wherever I want. Now, passive interface, another misconfiguration I want to add in there. Passive interface will destroy a neighbor relationship because unlike RIP, EIGRP requires two-way hello messages. So router 2 and router 3 have to continue to say hello, whereas RIP, if I put a passive interface on router 2, then what's going to happen is router 3 will still send its routes, router 2 will still hear them, accept them, and advertise them to router 1. Not so much with EIGRP. So what you'll see with EIGRP is you can approach it one of two ways. I can go and do router EIGRP 10. I can do a passive interface, and I can say the specific interface I want it to have passive, like 00/0. And what will happen then is it stops sending hello messages, and it will take the neighbor relationship down between the two. I could do that, or let me undo that. I can do a passive interface default, which turns off EIGRP on all interfaces, and then I can do a no passive interface on the interfaces that I want to run EIGRP. You'll see Cisco in high security environments actually suggesting this being the way you go, because when you combine this with a specific network statements, you almost have a double protection on making sure EIGRP does not run where it doesn't belong running. Now, it doesn't seem like that big of a security threat to have EIGRP running in uncharted territory, but it is. I've seen many networks taken down primarily by me, where I'm setting up a lab environment or something like that, not realizing that there's a ready and willing router waiting to form a neighbor relationship with whatever I throw at it. So one of the things is you want to make sure that you protect it using passive interface and very specific network commands. So speaking of security, what about authentication? Well, thankfully, EIGRP can enable authentication on a per interface basis. The way it works is you configure a keychain in global configuration mode. So I'm going to do keychain, and I'll just call it Jeremy. And in there, I'm going to define my key number 1, and we'll say the password of this key, or the key string more specifically, will be Cisco CBT. Right? Exit out of there. Then I can go into the interface itself that's connecting to the neighbor. I'll do interface fast Ethernet 0/0 and do IP authentication mode. And you can see that I have EIGRP as my only option, autonomous system 10. MD5 is the only mode there is. That's keyed message digest. It's never actually going to send this key across the wire. It's always going to send a hash version of that key, and some other data scrambled in there that only the other side will be able to match up and verify that we are the router that we say that we are, or at least that we're using this correct key string, right? So I've turned on authentication. Notice the neighbor goes down because I actually haven't done the other half of this, and that's going to be IP authentication keychain EIGRP 10, and we'll say the keychain is going to be, it's case sensitive Jeremy, right? Put that in there. Now I'm going to come down to router 2. Exit out. I'll do key chain Jeremy. Key ID, or hang on, key 1. There we go. Key string. Oh, how quickly I forget. Cisco CVT. Thank you. And by the way, the key ID, this key number right here, and the key string have to match. So you can't use key ID 10 on one and key ID 1 on the other. Even if they are the same string, they won't end up lining up. Okay, so now I'm going to go under interface fast Ethernet 0/0, and I'll do the IP authentication mode. EIGRP autonomous system 10 MD5 enter. We are now accepting authentication. Now I'll do the IP authentication keychain, and we will do EIGRP 10, and it will be Jeremy, right? And at this point, we should now see the authentication come up, or the new neighbor relationship form again, because the authentication is in line. So that is some of the misconfiguration. I'm trying to think of what else I had. Oh, one other misconfiguration: default route. I do not know why Cisco made it so easy to advertise default routes in other protocols, and not very easy to advertise a default route in the EIGRP realm. Well, I shouldn't say it's not easy, it's just unique, right? So the way that I do it, the number one most common way, is I go and I create my default route, right? IP route 0000 0000, and then I'll go to 68.110.171.97. That's our ISP, right? So there's my default route. I can verify it's in my routing table. The number one way that you can advertise that in EIGRP, or at least the way that I use, router EIGRP 10 redistribute static. And then I'll give it a metric of, let's just say, 1, 1, 1, 1. I know you're like, really? Really? It doesn't matter. It's just going to be a default route that's injected into the system. So I should now be able to come down here and do a show IP route and verify that default route is showing up as this. This is now being advertised from other things. Other ways that you can do it, and this. You'll see this one on Cisco's website all the time. I can't stand it. It's called the IP default network command. So what this does is identify some other route in your routing table as the default network. So, for example, we've got this 68 network, right? So let's just say I want to advertise that as my default network. I could do that 68.110.171.0. And it would actually, without the semicolon, it would actually take that and flag that as the default route. So all the other routers down the line will say, okay, if I don't know where to go, I'm going to send it to 68.110.171.0 and hope that it can get me there. And essentially it follows its way the whole way through the chain to the eventual destination of the ISP. The reason I don't like it is it's messed up. I mean, it's confusing. I mean, come on. Why a default route is supposed to be all zero? Why would I say, I don't know. There's analogies flooding through my head. I just can't even put words how crazy this command is to identify something other than an all zero route as the default route doesn't make sense, right? Another way that you could do this, you could go into router EIGRP and do network 0000. And that's only if you have the static route in there of all zeros like this pointing somewhere else. And you might say, well, yeah, that would make sense, right? Because you're advertising default route. But there's a drawback to this, and that is it will advertise every interface. Remember, when you first learned wildcard masks and you learned, okay, well, if I want to advertise everything, I could put 0000 with a wildcard mask of 255, 255, 255, 255, right? And that'll advertise everything into the OSPF process. It's usually where you first learn wildcard masks. Well, this does the same kind of thing with EIGRP, is if there's interfaces on your router that you didn't plan to be advertised, well, they just got advertised, right? So that is a drawback of using that network command. You could also do something like this. You could do on your edge router, I could go into interface fast Ethernet 0/0 and do an IP summary address EIGRP 10 and then do a 0000 and we'll just say administrative, well, if we want to do that. So the summary address will then advertise this and essentially use that as the default route. What's the drawback of that? Well, you suppress every other more specific route advertisement that's coming from router 1, because that's what a summary address does. So you may end up advertising that default route, but you do so at the price of hiding every more specific route that's coming from that device. I love doing those flybys because they so lay the groundwork for things that could go wrong. So what could go wrong with EIGRP? Number one is the interface could be down. Obviously, neighbors will not form if that's the case, just like we saw when I had that initial down interface between router 1 and the ISP. You could be using the wrong autonomous system number. Now, one of the things that you could do to verify that is do a debug IP EIGRP packet. I took a Cisco exam a long time ago, so this is not violating disclosure agreement because it was probably like 10 years ago. And we all know disclosure agreements don't last more than 9 years, right? So there was a scenario or something where I was trying to figure out why EIGRP wasn't working, and I didn't have access to the other router, meaning I only had access to the router that I was on. It's like, hey, you're not forming that neighbor relationship, what's going on? And I actually had to determine that the other guy was configured for the wrong autonomous system by watching the hello messages, by doing debugs of EIGRP in the simulator. So that's obviously something that could go wrong. Wrong network statement. A network statement identifying which interfaces run EIGRP. Obviously, if you type that in wrong, you're not going to be advertising correctly. Keep in mind, and this is such a common misconception, especially those that are brand new in Cisco, the network statement that you type in does not necessarily dictate what will be advertised. Like if I type in network 192.168.0.0, that does not necessarily mean that's going to be exactly what I advertise. That just says go to every interface starting with 192.168, again assuming I follow it with a mask, something like that, and enable it for EIGRP. Accept advertisements on those interfaces, but this does not necessarily mean that I'm going to be advertising to the world saying, hey, I know about 192.168.0.0. Passive interface or wrong subnet. So just like we saw previously, if I have passive interface turned on, neighbors aren't going to form. Or if I have two routers, let's just say router 2 and router 1 here, are on the same network but have slightly different subnet mask. It probably a misconfiguration. Maybe this guy's a /24, this guy's a /25. Neighbors will not form in that case. Authentication mismatch, just like we saw before. Maybe there's an ACL in the way, an access control list. Now, EIGRP is not using a port number, it's its own protocol number. It operates at the transport layer, so it uses protocol number 88, not port number. Again, so if you're allowing TCP, UDP, that's going to miss the EIGRP protocol. Protocol being the big picture. TCP, by the way, is protocol number 6. 17 is protocol number for UDP. So you don't need to know those things off the top of your head, but it is good to know that these protocol numbers can be filtered by an ACL. Last one is mismatched timers. Now, EIGRP is not like OSPF in the sense that you know what kills me? Those little bubbles that pop up on your computer. Like I'm sitting here recording my screen, and the little thing in the lower right corner pops up. I think it's Dropbox. I didn't even glance at it, but it's like 6 files were added to your, and there goes my brain. Whatever. Huh? What was I talking about? So mismatch timers, it's not like OSPF where it's not even going to form a neighbor relationship. EIGRP will form if the timers are different, meaning I have different hello timers or hold down timers than I did on the neighbor. Right? However, it will cause your neighbors to flap, because if this guy's saying hello once every, let's just say 10 seconds, and this guy once every 30 seconds, well, they're going to form a neighbor relationship, but this guy's going to consider him dead before he ends up saying hello again, right? So he's going to be like, oh, okay, oh no, you're back up. Okay, now you're done. So that's the flapping neighbors I was talking about. So when you're verifying this, of course, the hands down favorite is the show run section EIGRP, because that will show you exactly the commands that are typed in, and I will give you T-shoot tip number 1. Always verifying the running configuration is your best first step, because that's where you'll find the quick mistypes, the missed commands, the added commands that shouldn't be there. They'll all be shown right there in the running configuration. So I can verify my EIGRP config, at least the major chunk of it, using that command. I can verify what neighbors are forming by doing a show IP EIGRP neighbors. If my routes aren't showing up, this is the next place I look. Am I forming a neighbor relationship? And I can see in this case, yes, I have one neighbor relationship that is formed. I can type in the detail command and see a little bit more information around that. This guy's been running for 10 minutes and 59 seconds. I can see the restart time, how long since we last restarted that relationship or refreshed that relationship, iOS version, and so on. I can view my routing table, show IP route EIGRP, verify just the routes that I'm learning via EIGRP. Show IP protocols will give me the nitty-gritty detail about the routing protocol, and I can see the K values. That's where it gets its metric from, using bandwidth and delay. By default, I can see what interfaces it's running on, what summary routes it's been configured to do, which neighbor sources it's hearing from. All that using the show IP protocols, and then I can do a show IP EIGRP interfaces, which will show me all the interfaces running EIGRP and the number of peers that I've seen on each one of them. You now have the core troubleshooting of EIGRP. I hope this has been informative for you, and I'd like to thank you for viewing.